Hello everyone, welcome back to the channel. In this video, we'll be discussing about the last problem of today's weekly contest, count subarrays with fixed bounds. The problem states that you are given an integer array nums and two more integers min k and max k. You need to count the number of subarrays which satisfies these two conditions. The condition are the minimum of the subarray which you are currently taking should be equals to min k, and the maximum of the subarray that you are currently have is equals to max k. So you need to count how many such subarrays are there. Okay. So notice that these two conditions are straightforward if you are allowed to iterate over the subarray. But iterating over every subarray would require order n square time, and here n, which is the length of the array, is 10 to the power 5. So you can't actually enumerate all the subarrays in this particular case. That would exceed the time limit. So we need a better optimal solution where we don't need to iterate over every subarray. Okay, so let's look at it. Now notice that you like we have these two condition, right? Min k and max k. Like min of this subarray should be min k and max should be max k. And let's say min is 2 and max is 4. Now let's try to find out how many good subarrays are there in this particular example. So we have min 2 and max 4. We already said that we can't actually iterate over every subarray. So the second option that should come to your mind while dealing with subarray is, let's see if we can start with a particular index and count how many arrays are there or how many subarrays are there which starts with that particular index. If we are able to do so effectively, we can do this for every start index and we'll get the answer. We have solved several problems with this technique. I will link some of them in the comment below. So let's say you start here from 1. So can you form any subarray that starts with 1 and whose minimum is 2 and maximum is 4? The answer is no, because minimum itself is 1, right? So you can't actually form subarray starting with 1. So like starting with this is not possible. So that's good. We are able to identify this in order one time, which is very good. Now let's look at this particular index, start index. Now starting from this index, we need to find out how many subarrays are like how many subarrays starting with this index are there. Min k is 2, max k is 4. So here you can see there are quite a few. So this subarray is good, this is also good, then this is also good, but this is not good. So there are three subarrays which starts with this, like which starts with this index and which are good. Now, how to calculate these three effectively, we'll look at. But for now, let's assume that this is the case. Now, let's say you continue and you reach at this index. Okay. Now, how many subarrays are there which starts with this and min k is 2 and max k is 4? So notice that currently min and max is 2, so you need to increase the maximum. So you increase your array. Now you encounter 5. So max is now 5. So whatever you take afterwards, max will not change. So it means you hit a dead end. You can't go forward. So that's where you know that any array crossing 5 would not give you a subarray which have maximum 4. This is very similar to the case that we encountered with 1. Any array crossing 1 will not give us subarray which have min k 2 and max k 4. So you might like you will see the pattern here. Now if we are crossing anything smaller than 2 or anything greater than 4, it is sure that we will not get subarray. Like we will not get a valid subarray. Okay. So with this approach, we can say that s- anything which is smaller than 2 and greater than 4 are dead ends. We can't actually cross them. So if we can't cross them, each of these subarray are individual arrays, right? So you need to find out whatever algorithm you will apply. we can simply apply our algorithm in this particular, in all this piece of the array independently, and find out whether min k, like whether there, how many subarrays in this array are there such that min is 2 and max is 4. Does that make sense? So what we have done, we have identified that crossing any of these elements which is smaller than min k or greater than max k will not give us result in any way. So we can't cross them. So if we can't cross them, in a way, everything should be before, like end should be before this, right? And if end is before this, we can completely separate that particular array. So now what we have uh, a array, okay, and we need to, like we are sure that every element here is less than like is greater than equals to min k, and every element here is less than equals to max k. And now the problem remains same. We need to count the subarray with min equals to min k and max equals to max k. Now notice this. This problem is lot simpler. What we have said, anything here is not greater than min k, is not less than min k or greater than max k. So every, like, now you need to find out how many subarrays are there with min equals to min k and max equals to max k. So if I say that, okay, I, in like for, and let's say again the same trick, starting from this, how many subarrays are there? So if I start from this, min is 2, max is, like max is 2 with only this particular piece, right? Now as soon as you encounter 4, min is 2 and max is 4, so we satisfied our condition. Okay, now you can freely take all other subarray without any issue. The reason being, everything is less than, is greater than equals to min k, and everything is less than equals to max k. So once you encounter a valid subarray, everything after that, every subarray after this will be valid. Okay, so what we are coming at is, for each index we need to now find the first valid index, or the first index up to which the min is 2 and max is 4. And if we are able to find this, we can say all, like how many, let's say you, this is like you get this at this index, so how many subarrays are there is n minus this first index, the first good index. So here in this case n is 4 and this index is 1, so total 3 good subarrays are there which starts with 2. Now the only thing is how to find this index, the first index efficiently, how to find this efficiently. So notice that everything here is less than equals, is greater than equals to min k, and everything here is less than equals to max k. So if you, like for every index, like for every start index, if you are able to get a end index which is equal, like which includes 2 and 4 both, then you are done, right? So for this index we need to find first index up to which both 2 and 4 exists. So let's look at for this index, like this is the start index. So for this start index, you need to find the first index which include both 4 and 2. So 4 is already there. Now you keep on incrementing and you get 4, get to 2. So this is first valid array. Why this is first? Because 2 is there and 4 is there. So minimum would be 2 because everything is greater than 2, and maximum would be 4 because everything is smaller than equals to 4. So hope you get this. So you, what we need to find out now is the first index of 2 and the first index of 4 after this index. And if we are able to find that index, let's say this index is f, we can just add n minus f to the result, and that would be the result for this particular start index. So hope this makes sense. Now let's quickly look at the pseudocode and let's see if this is optimal even enough to pass the time, like pass the time complexity which is required. So for a particular array, what we are doing is we are iterating over every start index, right? And for each start index, we are first finding out the first index of max k, or here in this case max k is 4. first index of 4 after this particular index. Okay, so this is start index. Okay, uh, let me update it right away. So this is first index after this index, which is equals to max k. Now similarly we find out the first index after this index, which is equals to min k. Now both, like after finding both, we need to find out the last of them, right? Because let's say uh, first index is this, or let's increment the array. Let's say there is 4 after this. Okay, now let's say start index is 3. Okay, so if start index is 3, what will be your first index? Like this index max k, would be 4. This is the start index max k would be 4. Now what would be the uh, index min k would be this particular index. So out of these two, you have to take this one, because you want the index up to which both min and max is covered, right? So that's what we are doing. We are just taking the maximum, and finally we got the first complete index. So we'll just add n minus first complete index to the result. So hope this solution makes sense. Now what is the time complexity of the solution? We are iterating over every index. So n is there, right? Now what we are doing with each index, we are finding out the first index of max k and first index which is equals to min k. So both of this currently in worst case can require order and time if you do it naively, right? So we are doing order n amount of work. Like after that, these two are order one operation. So we are doing order n amount of work with each index. So complexity is still order n square, which is like equally bad as enumerating all the subarray. But you can remove this n easily. Notice what is this? It is the first index of max k after index. So this max k is fixed and min k is also fixed across the problem, right? So you can actually compute this beforehand. So you want for each index, I want what is the first index after me which contains 4. So how can you get this? You can just keep a suffix array, like you just do a suffix. Uh, you start from the end and go to the beginning and find out, and just keep on populating what is the first, like what is the last 4 that you see. So in this case, last 4 I see is at index 4. Okay. Now for this index, last 4 I see is index 4. Now for this index, last 4 I see is again index 4. Now for this index, last 4 I see is index 1, because current index is 4, right? Now similarly for this index, last 4 I see is index 1. So you can prepare this array easily, right? Now, once you have this array, you will do the same thing for min k as well. So what you want what is the last index, or what is the first index at which I see 2. So at this point, like starting, if you start from here, what is the first index you see 2? There is no element after this, right? So you can just put 5, like 5 denotes that there is nothing after this. Okay. Now, similarly for this one, the last index which you see 2 is 3, right? Now for this again, the last index which you see 2 is 3. Now for this last index which you see 2 again is 3. Now for the first index, last index you see 2 is 0, because current index is 2. So once you populate these two, now answering this and this is order one operation. You can just simply go to this array and find out what is the position. So just to take an example, let's say you need to find the answer for 3. You will go to this array and you will get index of max k. Index of max k is 4. 4 denotes the first index at which 4 occurs, right? Now you go to this array and find out index of min k. Index of min k is 3. So you get these two at order one time, and hence this n is not required. Okay. So hope the entire solution makes sense. So let's just reiterate over the entire solution. So initially we tried to find out, we just take a sample case where there are elements which is less than min k and greater than max k. Now, while doing while iterating over the sample case and trying to find out the possible subarrays, we figured out that crossing a element which is less than min k or greater than max k will not give us or will never give us a valid subarray. So what we have done, we have break our array into smaller pieces, and now we are saying that okay, I will solve the problem for each of these smaller pieces independently. Okay, so in this case there are four smaller arrays. Now what I will do, I will call a function, let's say f, for all of these array one by one. Now what is this f? F basically contains an array, and it says that like it requires that every element of the array is greater than equals to min k and less than equals to max k, and will give you the count of subarray with min equals to min k and max equals to max k. Now, while finding this, we just figured out, as everything here is less than equals to min k and less than equals to max k and greater than equals to min k, if we get to a point for every start index, if we get to a point which include both min k and max k, then that is the first good index. So everything after that would be a valid subarray, because everything after that is less than equals to max k and greater than equals to min k. So if we include that, our max will not change and min will not change because those two are already fixed. So with that approach, we went ahead and we say that okay, for each index we need the first index of max k and first index of min k. Once we got that, we got the first complete index, and we can just do n minus first complete index to the answer. Now, calculating index of min k and index of max k, if you do it naively, require order n time, and hence the entire solution will become order n square. So to optimize that, what we have done is we see that okay, for each index, the first index where max k exists, because max k and min k both are constants, right? So the first index where max k exists is something that we can pre-calculate using suffix array. Okay. Now for this we calculated what is the like for how we do that. Now for each index where 4 occurs, it will be like the value for that would be that index. Now everything after that would just be the first 4 after this. The first 4 after this is the first, like this particular value. So we just copied over this 4 here, copied over this 1 here. Similarly in this case, we copied over this 3 here, and like if there are indexes before that, we'll copy over 0 until we get more 2. So with these two subarrays, we are able to find out these two values in order one time, and hence the entire complexity of this would reduce to order n. So hope the solution makes sense. Let's look at the code. Now the code is simple. What we have done, as said, we will partition the array into good subarrays. Into good array, which what is good array? Everything there is less than equals to max k and greater than equals to min k. So if there is a point which is less than min k or greater than max k, we know this is a bad point and we can't cross this point. So a good part ends here. Now for this good part, we will just call our function with this good part and min k and max k. This will return the result of this particular part. Now we'll clear out the good part because our next part would start from here and we'll continue. Okay. Now at the end, there might be a case where the last there can be some good part left. So for let's say let's look at this example. So here good part would contain the entire array. So at the end we will have some good part. So let's calculate the value of that good part as well. Now how to calculate the value for single array? We have already discussed. We will find out the last max position and last min position beforehand. And how we will do that? We'll say that what is the value of the current position. If it is max, then it is j, otherwise it is the next position. Now once we have these two value, we'll just find the first complete index and then just add it to the answer and minus first complete index. Sorry. So hope this entire solution makes sense. If you have any doubts in this problem, please post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe to the channel if you haven't already. Thank you.